Hello, everyone. Back again for our final installment in the screencast on Chapter 15, Object-Oriented Programming in R. We are working with generic function, object-oriented programming. Last time, we learned how to write our own methods for existing generic functions. This time, we're going to learn how to write our own generic functions, followed by methods for them. So generic functions are really make the most sense when they correspond to tasks that are so commonly performed that many methods will be written for them. And so that way users will just get in the habit of trying out the generic function on some object they've generated just to see if somebody's written a method for it. And so that's why print and plot, they're such common tasks, they get a lot of methods written for them. Summary, str, there are several other examples in R that just where the generic function has a ton of methods. It doesn't really make a lot of sense to write generics that will only ever have a couple of methods attached to them, because the flow of user work and thought will not necessarily be directed toward them. But it really would be a good idea for us to see how generics do their work. And so we'll just construct a little artificial example here. It's actually drawn from the standard documentation on the R language. It's not original with me. But we'll write a new generic along with a couple of methods for it. So first of all, I want to create some objects that have a particular special class. So here are two objects of class Cartesian point. So point one here is just a list with two elements named x and y, and the values are 3 and 4. So the idea is it's the point 3, 4 on the regular Cartesian plane. And so I'm saying that the class of point 1 shall be, quotes, Cartesian point. So I'm just making up a class name for this R object, this simple little list. And point 2 is a similarly set up. So it's the point 25 on the Cartesian plane. Now, many of you will know that Cartesian coordinates are not the only way to represent the location of a point. You could also use polar coordinates. And the way polar coordinates works is there's going to be two numbers associated with the point. The first number, r, is a non-negative real number that represents the distance from the origin to the point. So how far away is the point from what we think of as 0, 0, the origin? And the other number is theta, the angle measure between the positive x-axis and the ray that goes from the origin to the point. And we'll measure that in radians. 2 pi radians makes a whole circle. So we're using radians and not degrees. So let's construct a couple of little lists that will give the class polar point to. And so the first one is a point that is 2 units away from the origin, and it makes an angle of pi over 2 with the positive x-axis. So it's actually 2 units straight up from the origin. It's the point 0, 2 in regular Cartesian coordinates, but here we are listing it in polar coordinates. And the second point, this point 4, is 1 unit away from the origin, makes an angle of pi with the positive x-axis. So actually it sits along the negative part of the x-axis. It's the point -1, 0 in regular Cartesian coordinates. Okay, so suppose we would like to find the x coordinate of a point, the x coordinate in Cartesian coordinates for a point. If your point is of class Cartesian point, then that's really simple. You just take the x element of that point. You just look into the list, you grab the element named x, and that gives you the x coordinate. But if the point is given in polar coordinates, if it's one of these objects of class polar point, then you're going to have to convert the thing back to Cartesian coordinates. And so those of you who studied polar coordinates will remember that the way to convert back to find the x coordinate is to simply multiply r by the cosine of the theta angle. And the way to find the y coordinate is to multiply r by the sine of the angle. So if you've got one of those points that's a polar point, like point 3, then the way to get the x coordinate in Cartesian coordinates for that point would be to take its r and multiply by the cosine of its theta. And for that particular point 3, the result is this number, and it's in scientific notation. It's 1.2 times 10 to the minus 16th. So it's 0. There was just a tiny bit of round off error in the math computations. So let's write a generic function for finding the x position of a point. So we'll call it xpos. It's a function of x, and that's expected to be the point that's fed in. And it just says use method xpos. But of course, we got to make a method for it to use. So let's write xpos dot Cartesian point. And so that's a function of your point, and it's the x, it's the element of that list that is named x. Remember, when a Cartesian point comes to you, it has x and y elements, and we're grabbing the x element. On the other hand, like, what if the object is of class polar point? We need a method for that. So we have xpos.polarPoint, and it's a function of our point, and it's the r component of the point times the cosine of the theta component of the point. So now that generic function has two methods that it can pass its input into, depending on the class of the input. And so, for example, take point 2, which was one of those Cartesian points. If you put that into xpos, it's going to get passed over into the xpos.Cartesian point, and it will pull out the x element. And that was a 2. The x coordinate was a 2. On the other hand, take point 4, which was a polar point. Well, if you ask for the xpos of it, then we're going to pass over to the polar point method and do the math conversion and get out -1 for the x position. In your homework for this chapter, you're going to write a generic function ypos and provide a couple of methods to it so that you can get the y position of points of either class, whether they're Cartesian points or polar points. And you'll work the same way. So that's it for us, and good luck on all the homework. Populate the discussion boards with questions as you have them, and see you soon on Zoom and other such places.